Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve next question, number 11 of 2017 NEET physics paper. Students, let us solve question number 11. Two rods A and B of different materials are welded together, as shown in figure. This is one material, this is another material. So we have two different materials, one, and this is the second one. Welded together, their thermal conductivities are K1 and K2. Here the thermal conductivity is K1 and here it is K2. As a figure, their thermal conductivities are K1 and K2. The thermal conductivity of the composite rod will be of the combination. So the area of cross section here and there, here not mentioned, they should have mentioned two rods of different materials. So we'll assume that this area cross section is A and its area cross section is also A. The temperature is T1, T2, so here the temperature is T1 this end and here the temperature is T2. The distance, the length is D. D is the length of the rod. So we know that this is like when current flows, heat current flows, the current will be the sum of the heat currents. Suppose the current that is passing through here is H1 and here the current that is passing is H2. So the total current will be H1 plus H2, the heat current. This is equivalent H equals to H1 plus H2. Now from thermal conductivity we have one expression which is given by if there is a conductor, and which is maintained at temperature difference, suppose T1, T2, and the distance is suppose D. The quantity of heat that is flowing through this is Q by T, the quantity of heat flowing per second, which is I call heat current. That heat current is equal to some constant that is called coefficient of thermal conductivity, which is here it is K1, K2. If this is K, then I write K multiplied by A is the area cross section, and the temperature gradient, that is T1 minus T2 over this distance D. This is the formula that we are going to use. So for this upper rod and the lower one, for this upper rod we'll use K1 only, and everything will be same because this is A, this is also A, this is D, this is also taken D. There's nothing going to change, only thing is K1. Similarly for H2, this part here it will be K2, and you add them up to get the equivalent value. Now if I think of the total composite rod, then suppose this composite rod, now this will be having area cross section 2A, distance is D, suppose the heat that is flowing is H, and the equivalent K I don't know, that I'll call K equivalent. Then for this composite rod having area cross section double, I'll write H equals to K equivalent area 2a, and temperature will remain the same, that is T1 minus T2. The difference of temperature divided by the distance will remain the same. So these are the equations I'm going to write. This is for composite one. For single H1, it will be K1A T1 minus T2 over D. H2 will become K2A temperature difference divided by D. So from here we have the equation that H is H1 plus H2. If I put that value here, what I'll get, I'll just substitute these values over here. So the H value is K equivalent 2 times area into temperature difference divided by D, that will remain the same, equals to H1, which is K1, area pressure is A, T1 minus T2 divided by D plus K2 A T1 minus T2 over D. This D will cancel out, A will cancel out, T1 minus T2 D, T1 minus T2 D, T1 minus T2 D will cancel out, A will cancel out. What is left is 2 times K equivalent equals to K1 here, K2 there. So from here K equivalent is equal to K1 plus K2 divided by 2. So the equivalent thermal conductivity of the composition, the equivalent thermal conductivity of composite material will be K1 plus K2 divided by 2. If you see the options, then K1 plus K2 divided by 2, it is option number 2 is the right answer to this question. Okay, thank you.